Welcome back to the GCSE Maths Pro YouTube channel. Today's video is a summary of the whole topic of perimeter. So we will be covering a couple of questions on each of the following: perimeter of some basic shapes, circumference of circles and perimeter of semicircles, the arc length of a circle sector, and finally, perimeter mixed with algebra. If you would like to look at any of the full videos for these topics, they will be linked down below in the description. So first of all, we have to understand what is the perimeter of anything in general. And mathematically, the perimeter means adding together all of the outside sides. So in terms of a rectangle, or also a square, which has 4 sides, you would need to add together all 4 sides. In terms of this triangle, you'd just add together these 3 sides that you can see. Now in terms of this rectangle, you can see we've only got 2 sides labelled. But that's obviously because with a rectangle, the opposite sides are the same, aren't they? So for example, this top side is also 13, and this left side is also 5. So the perimeter, if I just put P, would be 5 plus 13 plus another 5 plus another 13. And you would just literally add them all together, which should give you 36. In terms of this triangle, again, just literally add together all of the sides that you can see. Now you can see all of these 3 sides are different, hence why they're all labelled. So I just need to do 4 plus 5 plus 3, which will give me 12, again, centimetres. Okay, so the next shapes we have here, we have obviously a parallelogram on the left, and then we have this trapezium on the right. So working out the perimeter, as we said, is obviously just adding together all of the sides. Now with the parallelogram, we've only been given 2 sides, but it is basically the same idea as a rectangle, isn't it? That, for example, the top and the bottom are the same length, aren't they? That has to be 8.5 as well. And the left side and the right-hand side have to be the same as well. So this is also 3.75. So we just need to add together all 4 of those, or just double each of them. So the perimeter is 8.5 plus 3.75, and then effectively that times by 2, isn't it? Or you can add them manually, whichever you prefer, which gives us 24.5. So that is it for the parallelogram. Now for the trapezium, because all of the sides in this case are different, you can see that we've been obviously given all of the sides. So all I need to do for that one is just literally add them together as they've been shown. So I've got 7.9 plus 4.8 plus 11.3 plus 5.4. And for this one, that gives me 29.8. So that is it. You're literally just adding together all of the sides. Now, obviously, they can make it a little bit more complex with using compound shapes like this. Compound shapes is where you have a shape that is obviously made up of 2 other shapes. So for example, here, if I were to split this, that's obviously 2 rectangles, isn't it? They've stuck them together. So the perimeter of the shape is all of these sides added together. But as you can see, before I even start with adding them, I have got 2 sides missing. Do you see this horizontal one here and the vertical one on the right? So I'm actually going to have to figure out those missing side lengths before I can add them all together to get the perimeter. Now, a lot of people kind of get stuck here and they think, oh, just kind of look at it and go, well, it's roughly, maybe half, or it looks like it's half and half. I'm going to just split 14 in half and put 7. Anything that's drawn in your exams, unless it says otherwise, is not drawn to scale or is not drawn accurately, okay? So we can never really rely on assumptions. I'm assuming that that's half, for example. I can't rely on that, even if it looks exactly half, which I know in this case it doesn't, but even if it did look like this vertical bit was exactly half of this whole tall bit, you can never assume that. There will always be enough information written down for you to actually work it out properly. In this case, we're going to look at, obviously if I want to work out this vertical side, I need to compare it with the other vertical sides. So the whole thing is obviously 14, that's fine. However, if I then look at this other vertical part, which is 8, can we see that the 14 is the whole height of the shape? And then the other 2 vertical sides, if you were to actually line them up with each other, would make up 14, wouldn't they? So that's how I know how to calculate this missing piece here. I know that it must be 8 plus whatever this one is to equal 14. So all I need to do in this case with the vertical missing side is just do 14 take away 8, which will give me 6 centimetres. So as you can see, it's not exactly half. It's close, but not exactly. Now I'm going to do exactly the same thing but horizontally, because we can see this other missing side is horizontal. So the missing side is here. Obviously the whole of the shape horizontally is 11 centimeters across, and then in my other horizontal part is the 2 centimeters up here. And again, if I were to line them up, like let's say here, that's obviously still 2 centimeters here, isn't it, for example? So if that's 2 centimeters, and then I know that the whole thing is 11 across, then I can work out the missing piece by just doing 11 take away 2. So that must be 9. Now, finally, to actually work out the perimeter, as we said, 14 plus 2 plus 8 plus 9 plus 6 plus 11. And you would just add those together, which should give you 50 centimeters. That's it, that's the perimeter. So this first page is for you to write down or take a screenshot of. We've got the formula for the circumference of a circle. Now here I do actually have two formulas. They are exactly the same thing, right? So they're both for the circumference. It just depends on which one you personally prefer to memorize. So you've got either 2 pi r, where we're focusing on the radius, or pi d, which is the diameter. It's literally a personal choice. They're both exactly the same thing, because obviously 2 times the radius is the diameter, isn't it? So it's exactly the same thing. Whichever of these two formulas you prefer, that's the one that you go with. So we're just going to jump straight into it. It says work out the circumference of these circles. I've written down both of the formulas up here so you can choose. So I'm going to be using pi d, but you can obviously work it out with 2 pi r and just check if you've got the same answer. So the first one we've got 8 centimeters, which you can see is the radius, isn't it? So in terms of doing pi d, I know that if the radius is 8, the diameter is going to be 2 times 8. Now, I don't necessarily write this down, I kind of just do this in my head, but just so you can see where I've got it from. The diameter is actually then 16, isn't it? All the way across is the diameter. So then to find the circumference, which I'll put C for circumference, I do pi times 16, and then I'll put it in my calculator. So pi times 16. Obviously it's 16 pi, but as a decimal, let's say to 1 decimal place is 50.3. Okay, so that's the circumference. Now the circumference is just a very specific word of saying the perimeter. We're saying what is around the outside of the circle, okay, the length of the outside of the circle. With circles we just use the word circumference instead of perimeter, but the logic is the same thing. Okay, so as you can see with these ones, we've still got the same question, work out the circumference of the circles. However, we're now given this measurement all the way across the circle, which is obviously then the diameter. So in this case, I can just go straight into doing pi times the diameter. So pi times, in this case, 10, and then I'll put it into my calculator. Pi times 10, again, obviously 10 pi, but if you press the SD button here, just above the delete button, it will convert it into a decimal for you. So to 1 decimal place, we've got 31.4. The next bit we're going to look at is working out the perimeter of these semicircles. So we're using perimeter now because obviously it's only half of a circle. Now, in this case of a semicircle, we've actually got 2 sides, haven't we? If I go back quickly, a circle as a whole is just one side, isn't it? That's why I just worked out the circumference and that was it. For a semicircle, I've got this arc, which is obviously half of a circle. Then I've also got this straight line here. That's 2 sides that I need to add together. So that's why we're calling it the perimeter now, because it's not just the circumference anymore, is it? In terms of a circle, it's half of the circumference plus another side. So firstly, I'm going to work out the circumference of, if you imagine this circle to be the whole thing. If you imagine it to be the whole thing, we're still going to do 2 pi r or pi d, whichever you prefer. So in this case, I've got the radius, which is 7, so I would do the circumference pi times 14, because obviously 2 times 7 is 14. So pi times 14 gives me 43.98. So in this case, I'm going to write down a couple of decimal places because I've not got the final answer yet. So I'll put 43.98 down. Now, the only thing to be bearing in mind in this as well is that obviously that's the whole circumference if that were to be a whole circle. We've actually only got half of the circle, haven't we? We've got this arc, which is obviously exactly half. So therefore, I actually need to take my answer and divide it by 2 because I only want half of that circumference, don't I? So just remember, if it's a semicircle, we only want half. So it's going to take my answer here and just directly press divide by 2 so it copies the answer. So I don't have to lose any decimals. Obviously it's telling me it's 7 pi, but if I were to put it as a decimal, we've got 21.99 roughly. And again, this isn't the last bit, is it? So that's the arc part. Okay, so that's the green bit, but the perimeter is, as we said at the start, including this other side. Now, this side here, they've given us the radius, which is halfway, but we know from one side of the circumference to the other side of the circumference is the diameter, isn't it, if it goes straight through the middle? So I know that this is the diameter, which, as we said, is 2 lots of the radius. So my total perimeter, I'm going to just put it up here, perimeter is obviously the 21.99 plus the diameter, so 7 plus 7, or if you want to just write it as 14 directly as the diameter, that's fine. So we're going to add those. So my answer plus 7 plus another 7 gives me 35.99. Now this is the final answer, so I'm going to round it. If I round it to 1 decimal place, that would actually become 36, wouldn't it? So I've got 36.0 to 1 decimal place. Okay, this one's very similar. We now have a quarter of a circle, and we're going to work out the perimeter. So in this case, the quarter of a circle actually has 3 sides, doesn't it? So it's got this arc, it's got, and then 2, this is obviously a radius, and that's a radius, isn't it? So I know that that one's also 4.5 there. Just going to label that. So I'm going to work out the arc first. We're still going to work out the circumference, if you imagine that to be a whole circle. So we've got pi times the diameter. Now the diameter is obviously double the radius, so 4.5 times 2 is 9, isn't it? So we're going to need to work out what pi times 9 is, and that should give us 28.27, I'm going to write down. Now, in this case, that's again obviously the whole circumference of the whole circle. This one we're not going to half it because we've not got a semicircle, have we? We've actually got a quarter of a circle. So in that case, I'm just going to divide it by 4. I only want 1/4 of the whole thing, don't I? So therefore, 28.27 in this case divided by 4. So take your answer from that, just put directly divide and then 4. It will copy all of those decimals for you. So we've got 7.068 ... Just going to write down a couple of the decimals. So that's the length of the arc. So just double check. Do I need to find the circumference? Do I need to half the circumference? Do I need to divide it by 4? So that's that bit. But then again, remember, we've got 2 other sides we need to now add on to get the whole perimeter. So the perimeter as a whole is obviously the 7.068 ... plus 2 lots of 4.5, as those are the other 2 sides that we're missing. So I'm just going to put add, so it copies all of those decimals again. 4.5 plus another 4.5, 16.068 ... Now I'm going to round it to 1 decimal place. That would give me 16.1. And that's it. There's your answer. So here we've just got the formulas. I've written it twice, as if you have seen the previous video on circle circumference, you'll know that there are 2 ways to write down the formula for a circumference of a circle, and it's basically just your own personal choice. So you can see here we've got the 2 pi r option and the pi diameter option. It's completely up to you, that's why I've put or. So I've got pi d as my option because that's the one I prefer to use as a formula up in this corner. So in this example, work out the arc length of the sector. Here we've got 58 degrees as our angle and 6 centimeters as our radius. So the arc length is pi times the diameter. Now in this case, obviously with sectors, you're most likely to be given the radius, but I know that the diameter is 2 times the radius. So I know that's actually going to be 12, isn't it? Pi times 12 times by what fraction of the whole circle am I working with? Well, I've got 58 over 360 degrees. And then we just put it in the calculator. So pi times 12 gives me the whole circumference, and then I actually only want 58 degrees out of the 360. And as a decimal, that gives me 6.07 ... So I'm going to round that to 6.1. They should tell you in the question in an actual exam paper what to round it to, so don't worry about that. In this case, I'm doing 1 decimal place. And that's literally it. Okay, this time it's very similar. The only difference is they've said work out the perimeter of this sector. The perimeter is, as we know if you've seen the past few videos, is all of the sides added together. So yeah, we do have the arc length here, but we also have these 2 other sides, which that's a radius and so is this, isn't it? So that's another 19. So in this case, we're going to work out the arc length first still. But we're also then going to have to add on 19 and another 19 to get the whole perimeter. So first of all, let's do the arc length. Same formula as before. Pi times the diameter, which I know is 38, because 2 times 19 is 38, times by the angle, 211 over 360. So pi times 38 times 211 over 360. Which gives me roughly 69.97. Just going to write down a couple of the decimal places there. Okay, so that's the arc length. That's just this curved bit. Now though, if I want the whole perimeter, I'm going to need to take that 69.97 and add 2 lots of 19 because there are 2 other sides. So I'm going to take my answer, I'm going to put plus, and it'll copy that whole answer there. 19 plus another 19, which gives me 107.97, which if I round it to 1 decimal place is actually 108, isn't it? 108.0 to 1 decimal place. Okay, there we go. So that's the only difference. If you double check, have they said arc length, which is just the curved bit, or have they said perimeter, which is all of the sides added together additionally? So it's an additional step at the end. Okay, again, we're getting a little bit harder again. So the perimeter of the rectangle is 64 centimeters. The length of the rectangle is 3 times the width. Work out the length and the width. So we've not even been given any information in terms of actual numbers here of the length or the width. I can create the same equation I had before, perimeter equals, and then how I would work out the perimeter. Now you might think, oh yeah, okay, I've got the, let's say length and width. You can use whatever letters you want, it doesn't have to be x. However, if I use those 2 different letters, if I have 2 letters in an equation, I can't solve it, I need that many equations. So that's why you have simultaneous equations, right? Where you have x and y, you have 2 equations. Well, I guess I could create 2 equations, but I think that would just be a bit more complicated. The most obvious equation that I could create is the one we just said, perimeter, so 64, is equal to, and then all of the sides added together. So what that tells me is I would ideally just have 1 letter. So I'll show you how I'm going to do that. I always label the smallest thing x, for example, whatever letter you want. So the smallest side is obviously the width here, isn't it? That's x, that's also x. Now the length, I'm going to say the length is this longer one. I want to write that in terms of x. Obviously it's not also x, is it? Because they're clearly not the same length. I know it's not drawn accurately, but you can assume they're not the same length because they've told us in the question that the length is 3 times the width. So if the length is 3 times the width is x. Think about how could I write the length with an x but be the right scale? Well, if it's the length is 3 times the width, then that just means 3 times x, doesn't it? As in 3x. So that's what I'm going to do. I'm going to use everything in terms of 1 letter, just so I can stick with 1 equation. So I'm going to do the same thing as before. Obviously I know the perimeter is 64, so I'm going to have 64 equals 2, and the way I would normally work out the perimeter is just add the sides together, isn't it? So x plus 3x plus another x plus another 3x. I've created my equation. I can almost forget about the context for a second and just go, right, let me just solve that equation. The right hand side, I can collect the like terms. They're all x's, so I just need to add them together and count how many there are. So there's actually 8x there. 64 is still the same. And now I want to solve it. I want to get x on its own. So instead of 8x, I just want 1x. So I need to divide both sides by 8. Obviously 64 divided by 8 is still 8. So x is equal to 8. Now, they've asked for the length and the width. So we know, because x was the width, wasn't it? The width is 8. However, don't forget that you need to go back and work out the length. Okay, fine. If x is 8, what is 3x? Well, obviously that's going to be 3 times 8, isn't it? So 3 times 8 is 24. And that is the length. So just go back and input whatever you've worked out x to be into this relationship, which is 3 times. So 24 centimeters. Now we've got 2 shapes here. So it says the perimeter of the square is the same as the perimeter of the rectangle. Okay, so they have the same perimeter. Now that sentence is going to be our equation right there. Wherever you've got an is, that basically means equals to, doesn't it? So that's how we can use this information to create an equation. So work out the width y of the rectangle. Okay, looking at the square. A square obviously has all of the same sides, doesn't it? the square, that's just the definition of a square, all of the sides are the same. So I've got 5 here, 5 at the top and 5 on the right. So I could just go ahead and work out the perimeter of the square immediately. So the perimeter of, try and draw a square there, is 5 plus 5 plus 5 plus 5, or 4 times 5, however you want to write it, 4 lots of 5, that gives me 20. Okay, well that's the left-hand side of my equation, isn't it? If you think about it like that, perimeter of the square, which is 20, equals the same as the perimeter of the rectangle. So the perimeter of the rectangle, a bit more obviously a rectangle, I'm going to write it in terms of algebra. So I know that this side is obviously also 2, and that has to be also y. So I've got 2 plus y plus 2 plus another y, which if I simplify it, collect the like terms, I get 2y plus 4. So, and the perimeter of the rectangle is 2y plus 4 for now. Do you see how I've created that equation? I can now write that as 20, as in the perimeter of the square is 20, is equal to, is the same thing as, the perimeter of the rectangle, which is 2y plus 4. That's my equation now. And again, we're just solving it. We're just going through algebra and we're solving equations. So I need to solve it for y. So I'm going to move, obviously, the 4 first. It doesn't really matter. You can do the 2 first if you want, but I prefer to do the 4. Minus 6, that's the opposite of plus. So I get 16 equals to 2y. And then I'll bring it over here. We now need to divide by 2, don't we? Because we want just one y. I don't want 2 lots of y. So 16 divided by 2 is 8y. So it says work out the width y of the rectangle. Well, that is it. It's 8 centimeters. So for this one, the perimeter of the sector is 30.3 centimeters. Work out the angle. So we've actually been given the radius. We want to know the angle. So I'm going to write out, I guess basically build my formula for perimeter, because we haven't exactly memorized a formula, have we? But when I work out the perimeter of a sector, I obviously do the arc length, which is pi times diameter times the angle over 360. You might use 2 pi r, that's absolutely fine. And then after that, we have to add on 2 lots of the radius, don't we? Because it's like a radius here plus another radius here. Now, I ideally want to only have 1 letter, because I can't solve an equation if I have 2 letters. In that case, you'd need simultaneous equations, wouldn't you? You'd need 2 equations for 2 letters. So I've already used d here for diameter, and actually, radius plus radius is obviously 2 radius, which equals the diameter, doesn't it? So in this case, I'm going to put plus the diameter. If you're using 2 pi r at the start, put plus 2r. Okay, so just whichever letter you've gone with for your formula, stick to that. So we're technically adding a diameter, aren't we, if you think about it at the end. That's the perimeter of this sector, which we now know is equal to 30.3. So I'm also going to sub in the other thing. I know the radius is 8.2. If my radius is 8.2, my diameter is 16.4, isn't it? 2 lots of that. So I'm going to sub that in. Again, if you're using 2 pi r, sub in just 8.2 as it is. So I've got pi times 16.4 times theta, which I don't know. You could use another letter if you want. You could use x or whatever, but I'm going to leave it as just that symbol. Plus the other diameter, which is 16.4, and that equals 30.3. I think the easiest thing to do is to move the 16.4, isn't it? Let's just subtract that straight away. Take that away because obviously it's currently added. So then my brackets will open up. I've got all of this times together, which equals, so we've got 30.3 minus 16.4, which gives me 13.9. So we've got 13.9 here. Now, obviously, I'm trying to get to the point where I've got the theta, this angle, as my subject. So I think what I might do now is times both sides by 360. Because all of this is already multiplied together, I don't need to worry about the left side. It will just cancel it out, won't it? But I obviously need to times the right-hand side by 360. So 13.9 times 360 gives me 5004. So I've got effectively pi times 16.4 times theta equals 5004. Now, you might do this next bit in 2 steps. You might divide by pi and then divide by 16.4. That's fine, or whichever way round. However, because these two are multiplied together in themselves, I can just divide by both of them at the same time. So that's what I'm going to do. I'm going to take my 5004, divide it by, and I'll just put a little bracket, pi times 16.4. Okay, you can do that. Because when you times multiple numbers together, it doesn't technically matter which order you've times them in. So I'm just going to move them both across at the same time. So I've got for theta 97, and if I do it to 1 decimal place, 97.1. So therefore theta is 97.1 degrees. And that is to 1 decimal place. So thanks for watching this video, and again, if you would like to look at any of these videos in full or in more detail, they will be linked down below in the description.